Welcome. This video is over how to multiply decimals. So let's look at our number routine. In our number routine, we are going to be adding 5 tenths to 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 5 tenths. If you add this 6 times, 5 plus 5 plus 5 plus 5 plus 5 plus 5 is 30, carry to 3. You'll get 3 and 0 tenths are just 3 whole. What is another way to represent this? Half and half is 1 whole, half and half is 1 whole, half and half is 1 whole, 3. Do you know another way to do repeated addition? What's another word for repeated addition? What? Multiplication? You are right. So what is, you have 6 groups of 5 tenths. So that's 6 times 5 tenths. Today's video, we are going to be showing the different ways of multiplying 6 times 5 tenths. One way you can multiply is this way. Multiply it just as normal numbers. What is 6 times 5? 30. And then this is set in the tenths place, or product needs to be in the set in the tenths place. Another way to do it is this way. How many places are behind a decimal point? 1 place. Are there 1 place behind this decimal point for our product? Yes, there is. Another way of doing it is this is in the ones place times the tenths place. So our answer needs to be in the tenths place. So let's get to the foundation. Shade 15 hundredths on the hundreds grid below. The grid below represents 1 whole. So shade the 100 grid to determine the value of 3 groups of 15 hundredths. So here's one group of 15 hundredths, here's the second group of 15 hundredths, and here's the third group of 15 hundredths. So 3 groups of 15 hundredths are equal to 4,500. So 3 times 1500 is 4,500 hundredths. What is another way to represent? So how do you say 3 times 1500 in word form? 3 groups of 15 hundredths. What is another way to represent multiplication? What if you don't like multiplication? We have some kids who prefer repeated addition. 15 hundredths plus 15 hundredths plus 15 hundredths is 4,500 hundredths. Shade 3 tenths on the grid, hundreds grids below. The grid below represents 1 whole. So shade, what would shade 2 tenths of 3 tenths? So we need to shade 2 tenths of this. 2 tenths of 3 tenths is equal to what? So let's look at right here. This was 3 tenths. We shaded 2 tenths of the 3 tenths. What decimal or fraction is this? It's 6 hundredths of the whole grid. So 2 tenths times 3 tenths is 6 hundredths. So what is another way to rewrite 2 tenths times 3 tenths? What about in fraction form? 2 tenths times 3 tenths. And in our previous video, we have already learned how to multiply by fraction. Multiply the numerator, 6, multiply the denominator, 6 hundredths. And that's why this is 6 hundredths. Why is 2 tenths of 3 tenths a smaller product? Because let's think about it. We started with 3 tenths and we have 2 tenths here. Why is our product so much smaller than the original values, original factors? Because you're finding 2 tenths a part of 3 tenths. Here's 3 tenths, you're finding a part of it. You're finding part of a group. That is why it is smaller. Think about it. In previous lessons, we talked about you're multiplying the original value of 3/10 by a number that is less than 1 whole. When you multiply by a number that's less than 1 whole, the product will be smaller. If this had been greater than 1 whole, then our value or product would have been greater. Hopefully this is coming back a little. Now last one, shade 7/10. Highlighter. I will use this color. Shade in 7/10, 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, and 7/10. I would like you now to shade 4/10 of this 7/10. 1/10, 2/10, 3/10, 4/10. What part, fraction of this 1 whole did we shade? Let's see, it's all of this right here. 4 by 7 is 28 hundredths. So 4/10 times 7/10 is 28 hundredths. What is another way to rewrite 4/10 times 7/10? How about writing it in fraction form? 4/10 times 7/10 is 28 hundredths. That is where we got our answer. So this is the foundation of multiplying decimals. What did you notice as you were multiplying? Whoops. What did you notice as you were multiplying this? When I was multiplying this, I got 4 times 7. So you multiply it normally. 4 times 7 is 28. But why did this decimal right here go right here? Why is this in the hundredths place? Because we're multiplying a tenths place by tenths place. That would be the hundredths place. You're finding 4/10 of 7/10. You mean you're finding a part of the group of 7/10. That's why it has to be a smaller, the product is smaller than the original value of 7/10. So here's another practice as to how to multiply decimal. Without using a calculator, find a product of each problem below. So what's 12 times 3? 36. What's 24 times 13? 3 times 4 is 12, carry the 1. 2 times 3 is 6 plus 1 is 7. 1 times 4, a placeholder. 1 times 4 is 4. 1 times 2 is 2. This added up to 312. 8 times 9 is 72. And for this one, let me extend the page. 8 times 4 is 32. Carry the 3. 8 times 2 is 16 plus 3 is 19. Placeholder. 1 times 4 is 4. 1 times 2 is 2. This adds up to 432. Now, using a calculator, find the product of each problem below. If I multiply 12/10, 12/10 times 3/10, it will equal, oh, that is so weird. I don't know. Clear point. I don't think this one will let you. I do not think it will let you. You know what? I don't need a calculator. I can do this without it. 12 times 3, it would be this value. 24 times 13. Let's go back to our previous. It'll be, this is the answer. 8 hundredths times 9/10 would be 72 thousandths. And for this one, if 24 hundredths times 18 hundredths would be 432 10,000ths place. So the question is, what is similar about questions 1 through 4 to questions 5 through 8? Why are these similar to this? Well, from what I could tell, it seems like it used the same numbers. I see a 12 and 3, 24, 13, 8, and 9. But what is different about them? Well, 1 through 4 are whole numbers, while 5 through 8 are decimal numbers. What decimal point patterns do you notice in the problems? So let's look at this one. Here are the answers again. All right, let's look here. So what do you notice about the decimal point in the problem? So in last year at elementary school, you learned a little about decimals. So what can you recollect anything about decimals? Multiplication. Some of you will say this, because in previous years kids have said this. What I learned is there are 3 places behind a decimal point. So my product has to have 3 places behind a decimal point. That is correct. There are 4 places behind a decimal point. So my product will have to have 4 places behind a decimal point. There are 3 places behind a decimal point. Does this product have 3 places behind a decimal point? It does. There are 4 places behind a decimal point. 1, 2, 3, 4. Or there are 4 places behind a decimal point? There are. Some of you may say that. Another way of doing it is this way. This is in the hundredths place. This is the tenths place. We are finding 12 hundredths of 3 tenths. You're finding part of the group. So we know our answer has to be smaller. So it couldn't be 36 hundredths. You're finding part of a group. So the answer should have been 36 thousandths. So because hundreds times tenths is thousandths place. So using what we know about this, how do you multiply decimal? You just multiply normally, ignoring decimal points. Then put the decimal point in the answer. The answer should have the same number of decimal places as are in both the numbers you are multiplying. For example, y. Let's look at this. Let's estimate this. 5 and 1/10 times 1 and 3/10. If you estimate this, 5 times 1 is 5. So we know our answer has to be around 5. What place value is the 1 in? It is in the tenths place. What place value is the 3 in? It is in the tenths place. So if you're finding tenths times tenths, that would be the hundredths place. Is this 63 in the hundredths place? It is. Because 51 times 13 is 663. There are 2 place tenths times tenths, got to be in the hundred place. And is 6 and 6300 close to the estimation of 5? It is. Because if you had put the decimal point right here, this is not close to that. If you had put a decimal point right here, 5, the estimated answer, is not even nearly close to the actual answer. So let's try another example. 2 and 4/10 times 12 hundredths. This is in the tenths place, 1 place value behind the decimal point. There are 2 places behind a decimal point, so this is in the hundredths place. Let me erase that. If you multiply the tenths and the hundredths place, you get the thousandths place. And 24 times 12 is 288. This is in the thousandths place. So now we are going to practice some of this on your own. So let's estimate this before we even multiply. 3 and 1500, that is close to the whole number of 3. 2 and 4/10 is close to the whole number of 2. So I'm going to estimate this around 6s. There are 3 ways you can multiply this. This is up to you. One way to do it is this way. Some students prefer lining up the decimal point and affixing a 0 and multiplying like this way. Some students prefer the lattice multiplication. Actually, this isn't called lattice. I forgot what this is called. This is something they learn at elementary. Product. Something with product. Cross product. I don't know. I cannot remember what this is called. I'm sorry. But some kids prefer multiplying it this way. Partial product. Partial product. That's an elementary word. So this is 300. 300 plus 10 plus 5. And this can be broken down into 20 and 4, and then you just multiply. And while other kids prefer this way, just multiplying it as a normal whole number multiplication, 315 times 24. I personally prefer this one or this one. 4 times 5 is 20, carry the 2. 4 times 1 is 4 plus 2 is 6. 4 times 3 is 12. I am done with this place value, so I put a 0 right here. 2 times 5 is 10, carry the 1. 2 times 1 is 2, plus 1 is 3. 3 times 2 is 6. This adds up to 7,560. Let's think about it. We did estimate it in the beginning, so our estimate answer is around 6-ish. This is nowhere close to 6-ish. So where should the decimal point go? It goes right here. So is 7 and 5,600 kind of close to 6-ish? 6? It is. But however, can we do a more, other than estimation, can we do another way? How many digits or places, how many places are there behind the decimal point? 1 place, 2 places, 3 places. Are there 3 places behind this decimal point? There are. So that is another way you could have done it. Or hundreds times tens. Tens, hundreds, thousands. Tens, 100,000. Make sure there are thousands placed behind this decimal point. If you prefer the partial product, 20 times 300 is 6,000. 20 times 10 is 200. 20 times 5 is 100. 4 times 300 is 1,200. 4 times 10 is 40. 4 times 5 is 20. So what's 6,000 plus 1,200? That's 7,200. What's 200 plus 100? Is 300. What's 40 plus 20? That's 60. I kind of like partial product. 65, 7,560. And there are 3 places here. And if you prefer lining up like this way, again, there's nothing wrong with this way. If you are going to line it up, make sure you affix a 0 here. 0 times 5 is 0. 0 times 1 is 0. 0 times 3 is 0. We're done with this place value, so put a 0 here. 4 times 5 is 20. Carry the 2. 4 times 1 is 4 plus 2 is 6. 4 times 3 is 12. We're done with this one. You need 2 place value. You know what? I should color this a different color so you can see it. Because we are now multiplying in the hundreds place. So that's why you need 2 place values. 2 times 5 is 10. Carry the 1. 2 times 1 is 2 plus 1 is 3. 2 times 3 is 6. If we add this all up, we also got 75600. But how many places are behind the decimal point? Let me get my highlighter. 1, 2, 3, 4. So we need to make sure we have 4 numbers behind our decimal point. Hence, this right here. What do you prefer? Do you prefer multiplying by whole numbers and then moving the decimal point accordingly? Do you prefer partial product? Or do you prefer lining up the decimal point, affixing a 0? I am not going to limit you in your decimal multiplication. Pick one. Let's look at another example. Let's estimate this first. What is 2 and 1,200 times 12 and 410? If I had to estimate this, 2 times 12, I say is about 24-ish. Since this is more than 2 and this is more than 12, so probably 25, 26-ish. So which one do you prefer? Do you prefer straight up multiplying as a whole number and then moving in decimal? Let's see. Let's count. Let me highlight this. There are 3 places behind the decimal point. Do you prefer partial product? Or do you prefer lining up the decimal point, affixing a 0 here? What do you prefer? I'm going to try partial product. because I am very partial to it. 100 times 2. 1 times 2 is 2. There are 4 zeros here. 100 times 10, that's 1 with 3 0, 1,000. 100 times 2 is 200. 200 times 20 is 4,000. 20 times 10 is 200. 20 times 2 is 40. 200 times 4 is 800. 10 times 4 is 40. 4 times 2 is 8. So what is 20,000 with 4,000, 1,000? That's 5,000. So 20,000, so that's 25,000. 800 plus 200 is 1,000. 40 plus 40 plus 200 is 240, 280, 288. So if you add all this up, 8, 8, 2, 6, 2. So I got 26288. There are 3 places behind a decimal point. So I need to have 3 places behind my decimal point. So that means I say that the decimal point goes right here. And is 26 and 288,000 close to 24? Yes, it is. Remember I said I was going to estimate it? I said it's going to be around 25, 26-ish. I did actually pretty good. However, some of you may not prefer this way, partial product. Again, I'm partial to it. I do like it though. I prefer, so let's look at this one. 2 times 4 is 8. So we start with the ones place. 2 times 2 is 4. 2 times 1 is 2. We're done with this one. Let's put a placeholder here. 1 times 4 is 4. 1 times 2 is 2. 1 times 1 is 1. Since we are done with this one, we need 2 placeholders because we're in the hundreds now. 2 times 4 is 8. 2 times 2 is 4. And 2 times 1 is 2. If you add this up, whoops. I also got 26288. There are 3 digits behind the 3 places behind a decimal point. Where can I put it so there'll be 3 places behind my decimal point? Right here, and that is correct. So our last thing is you're going to be working with some word problems because in real life you don't go around to see decimals there and say, oh, let's just multiply decimals. There's always a context with it. At HEB, Peter bought 5 1/10 pounds of grapes. Estimate and find exactly how much did Peter spend. So that means he bought about 5 pounds of grape. Each pound cost 87 cents. So let's think. He bought about 5 pounds of it. And 87 cents is close to 90 cents. So 5 groups at 90 cents is $4.50. Or if you want to make it even easier on yourself, 87 cents is about close to $1. So it's going to be around $4.50, around $5. It's going to be actually less than because we did overestimate. So we know the answer is going to be a little less than $4.50. Good estimate. So how would you like to use partial product? If you prefer partial product, 5 and 1, that's made up of 50 and 1. 87 is made up of 80 and 7. So let's do partial product. 8 times 5 is 4,000. 80 times 1 is 80. 50 times 7 is 350. 7 times 1 is 7. So 4,350 plus 87. If you add this up, oh, I got 4437, but where does the decimal point go? Well, this is about 87 cents per pound. How would you write that as a decimal? So let's use my highlighter. I see 1 place behind a decimal point, 2 places, 3 places. 1, 2, 3. So that means it's right here. And it's about $4.04, and this rounds up. So it's about $4.44 if you buy 5 1/10 pounds of grapes at 87 cents for every pound. Is $4.50 a great estimating of that? It is. So that's one way you could have done it. Another way you could have done it is pretend it's just straight up regular multiplication. whole number multiplication, that is. 51 times 87. 7 times 1 is 7. 7 times 5 is 35. We're done with this one, so let's put a 0 placeholder here. 8 times 1 is 8. 8 times 5 is 40. If you add this up, you also get the same thing as the partial product. And for those who prefer lining up the decimal point, this is how you would line it up. 5 and 1/10, you have to affix a 0 here because it would look like this. Again, I do not prefer this way, but some kids do, because if you look at this, isn't this way, you're multiplying by now the hundreds and tens if you took away the decimal point here. 100, that's more work, more chances of messing up. So either use the partial product or multiplying just as whole numbers, in my strategy. Greg bought 8 2/10 gallons of gas, so about 8 gallons of gas, at about $2.02 per or for every gallon of gas from Costco. Estimate and find exactly how much did Greg spend. So he bought 8 gallons of gas. It costs about $2 for every gallon. So he spent about $16 on gas. Let's find the exact. Let's do partial product for those who prefer partial product. 8 2/10. That could be broken down as 80 and 2. 202, if you make this as a whole number, that would be 200 and just 2. So let's multiply this. 200 times 80 is 16,000. 200 times 2 is 400. 80 times 2 is 160, and 2 times 2 is 4. So we have 16,000. 400 plus 160 is 560 plus 4. So it'd be 16,564. Now let's, using my highlighter, let's count the number of digits behind it. 1 place, 2 places, 3 places. 1, 2, 3. So it's about $16.56 for 8 2/10 gallons of gas at $2.02 for every gallon of gas from Costco. Is our estimating good? It is. What if you do not like partial product? Let's multiply this as regular whole numbers. Would I multiply like this way or this way? Former or latter? This one. You may laugh and say, why would anybody do it this way? Oh my gosh. Over the years, I've seen it so many times. Hundreds times tens. So let's multiply this. 2 times 2 is 4. 2 times 0 is 0. 2 times 2 is 4. We are done with this ones place. So we need to add a placeholder. 8 times 2 is 16. Carry the 1. 8 times 0 is 0 plus 1 is 1. 2 times 8 is 16. Let's add this up. So, hey, same number I got like last time. There are 3 places behind a decimal point. So here I go, 16 and 564,000. And that is how you multiply decimals.